Next, talking about the ATS panel, automatic transfer switch. The name itself indicates transfer switch, means we are transferring the supply. We are taking a supply from one source to other source. Like for example, I am working with a project where I have two sources of supply. One is from the transformer, one is from the generator. So whenever if I have any kind of interruption from the transformer, I have to get the supply from generator, because in my project there is one more supply which is from generator. So this transfer I have to do in less than a minute, I can say, or in less than 5 seconds. As per the standard, it should be less than 5 seconds. But when you talk about a manual way, it takes something like 2 to 3 minutes minimum. So to overcome this delay of 2 to 3 minutes working in a manual way, I have got a new device which is called as ATS panel. So by default, when we have any kind of interruption from the transformer side, in less than 5 seconds, this ATS panel will send the signal to the generator. So this generator will provide the supply to all your essentials. Again, whenever the supply has been restored into the transformer, this ATS panel will turn off your generator and take the supply from your transformer. So this complete process does in less than 5 seconds as per the IEEE standard. Following? So whenever we have two sources of supply, we need this. Again, talking about Apfcp, automatic power factor correction panel, nothing but capacitor banks. Earlier, we used to call it as capacitor banks, but now we are calling it as Apfcp panel, automatic power factor correction panel. So what is the basic difference between capacitor bank and Apfcp? Like in your home, you are having some different machines. So all these machines, you are not going to use at the same time. Okay, some of the machines you are going to use at peak hours. Some of the machines you are going to use whenever there is a requirement. So here, what is happening? The amount of inductive load is not fixed. It's not constant. So whenever there is a requirement, automatically the power factor has to be maintained. So which can be done by means of Apfcp, automatic power factor correction panel. Next, we have the circuit breakers like MCB, miniature circuit breaker, MCCB, molded case circuit breaker, ACB, air blast circuit breaker, SF6 sulfur hexafluoride circuit breaker, VCB, vacuum circuit breaker, ELCB, earth leakage circuit breaker, RCCB, residual current circuit breaker, ROCB, residual overcurrent circuit breaker. So these are the different types of circuit breaker. So with this chapter concept, I say that just memorize this abbreviations and full form, because all these concepts in the future we are going to discuss in the circuit breaker calculations. Now, chapter 6, along with the specifications, okay, along with the theoretical informations and the calculations, there I'm going to explain about all those things. So just memorize the abbreviations over here. Next, we have the LBS, nothing but the load breaker switch. So this is actually a highly rated mechanical switch, which you can find especially at the main areas. Like if you're having any kind of, okay, huge size of machines, or if you have any kind of transformers, or if you have any kind of heavy loads, at that point of view, we are going to use this. These are manually operated. Again, we have the high tension switch fuse unit. That means at every high tension side of the transformer, nearby the distribution transformer, we have this panel board, because at high tension side, as we can see, we have 3 phases. So for 3 phases, we have different 3 fuses. It's called as HTSFU. On the roadside, you can see this panel. Again, you can see I'm talking about generator. So generator, basically we have a panel which is called as generator controller panel. So what we have in this generator controller panel, we have the voltage selector switches, ampere selector switches, automatic voltage regulator, auto main failure, breakdown voltage. These are the things what we have in the generator panel. So what is the requirement of voltage selector switch? Basically, generator, okay, is a rotatory device. It's not a static device. So if you're not going to maintain, okay, the generator, so definitely there will be a fluctuation in the voltage. So when you get a fluctuations at voltage side, definitely there will be a fluctuation in the current side. So to overcome that, we are having the automatic voltage regulator, which is actually called as voltage stabilizers. So we have this again, auto main failure and breakdown voltage. If there is any kind of error, so in that case, you'll be getting this signal. Means you have to maintain your generator in a proper way because of heat, because of your excessive RPM value, or because of not putting enough amount of load on generator. Also, you'll be getting this results. So some manufacturing companies, they have given some range, like whenever you're going to turn on the generator, minimum 25% of the base load you have to put. 25% minimum 25% to overcome these errors. Next, talking about the BIS, Bureau of Indian Standard. Okay, this is actually a specific standard which is followed in India for energy efficiency. Following everyone? Okay, this is actually a standard which is followed in India for energy efficiency. What is meant by energy efficiency? How to save energy, electrical energy I'm talking about. Next, we are having the CEB, Central Electricity Board. Okay, so in every country, we have one department which looks after the complete generation and transmission. So that is, I think, what Central Electricity Board department. Like in India, we have in New Delhi. Again, COS, changeover switch. Like earlier, we have discussed about the ATS, automatic transfer switch. So before the invention of ATS, we used to go with changeover switches only. So this is also a type of switch which we are going to use whenever we have two sources of supply. But this is manually operated switch, totally manually operated switch. Next, again, you can see we have the CPRI, Central Power Research Institute. Again, we have the CTRC, Central Tariff Regulatory Commission. So this CPRI is actually institute which works on the research and development of power. Research and development of power, like how we can able to track the energy, how we can save the energy, what is the best resources we can make, how to save the environment. All those things are with respect to your CPRI. Again, CTRC. Okay, these are the people who makes a tariff. Okay, like on monthly basis we are getting electricity bill. So who are framing all those charges? These are the people. Again, we have the GI, nothing but galvanized iron. It's a type of metal generally used for the earthing. Okay, generally used for the earthing. Even we have lux also. Again, we have the GLS, nothing but the general lighting services. This is actually a standard, okay, for the lighting people to find out number of lamps and to place the lighting fixtures. Again, we have the HBC, high breaking capacity and high rapturing capacity fuse. These are the two different types of fuses. Okay, which you can find in any of the fuse distribution boards. High breaking capacity, high rapturing capacity fuse. These are the two different types of fuses. Next, we have the IP, Ingress of Protection. Every electrical or a mechanical device will have the IP value. So what is meant by IP? This IP will specify the insulation level of the device. Like you can see outside to your home, okay, we're having different electrical and electronic devices. Like we can see we have cameras, we have street lights, we have different electronic we are having different electronic DVRs also nowadays. So all those are exposed to atmosphere. So exposed to atmosphere means what? It's exposed to rain, dust, everything. So if the insulation level is high, so what happens? These things will never harm your device. Insulation level will be maintained. So if the equipment is having the IP value more than 65, please make a note. IP is 65. If on your device, if they have specified something like 65, that means it is totally exposed to atmosphere. We can able to install this device totally exposed to atmosphere. Nothing to worry about the weather, like temperature, rain, dust, moisture, whatever we have.
Sir, usually this IP is specified by number, IP 45, 50,
yes.
55.
Yes, if it is more than 65.
This 55 represents.
That's what now.
I want to ask you this number 55. What does it represents actually?
It represents the insulation level of your device. Like when you talk about 40, there is very little amount of insulation level. That means it is totally concealed. It has to be totally concealed inside your home. Like when you talk about 50, you can able to place in so-and-so area. If you're going to talk about 60, you can able to place in so-and-so distribution board or any kind of panel board. If you talk about 65 or 67, in that case, this can be installed anywhere as per your requirements. Exposed to atmosphere or any kind of hot place, or it can be anywhere.
So it means we can say higher the number, higher will be the level of insulation.
Perfect. In a simple logical way, you can understand this.
What is the highest IP rating?
Till 80 probably. As per my experience, I have seen till 67, 68 only for solar panel inverters. You can see the solar panels are exposed to atmosphere. So along with solar panel, we have the inverter, okay, which is connected to your solar panel itself. So those boards will have 68, 67 value. As per my experience, I have seen this. But till 80 we have. In the manufacturing data, okay, in any of the catalog, they will specify till 80. Again, talking about OLR, nothing but overload relay. Okay, what is relay? what is meant by relay? Relay is actually a mechanism which is used to sense a fault. Relay is actually a mechanism. Please make a note of this. Relay is only a mechanism which is used to sense a fault or which is used to sense something, not only a fault. Even it can be a signal also, a good signal or a bad signal also. So I'm talking about overload relay. Every equipment or a device like transformer, machine, generators, you'll be finding this overload relay, because if you're going to overload your device, what happens? Okay, it may blow. So to overcome that, we are having this overload relay. So before crossing the limit itself, it will interrupt the supply. Next, we have the ELR, earth leakage relay. So whenever you have any kind of earth leakages, like you are touching your metallic body, like your laptop, or you can talk about your PC. So sometimes we are getting some least amount of current. You'll be getting some jerks. Okay, that is because of improper earthing or because of leakage in supply. So to overcome that, we have this earth leakage relays. Again, LED, light emitting diode, or a type of light. Okay, it's a type of light. Again, we can see we have the MSB, main switchboard. MSB stands for main switchboard, the switchboard which you have in your homes, where we have some different options to connect. You can able to connect. I'll be showing you the image or else. So in this switchboard, you can able to connect anything. You can able to connect your socket of 6 ampere, 10 ampere, 16 ampere, 20 ampere. You can able to connect your switches of 1-way, 2-way. You can able to connect your LAN ports also, your TV port also, even your USB port also, even your bell button or a push button. All those things you can able to put into this lighting switchboard. Following? All those things you can able to place it over here. Next, you can see we're talking about the NGR. Okay, neutral ground resistor. This is actually a type of connection done with your transformer side. Neutral ground resistor type of connection you can write or you can remember. Again, OCR, over current relay. Relay, we are talking about relay again, means it's mechanism to overcurrent, to overcome the overcurrent. Okay, to overcome the overcurrents. Sometimes we'll be getting some overcurrents. So to overcome that, we have this relay. Again, OLTC, on load tap change. So what is transformer? Basically, basic function to step up or to step down the voltage. So during the on load condition, if you want to step up or step down, in that case, we have this option called as OLTC, on load tap changer. During the on load condition, you can able to step up or you can able to step down. Again, we have the OTI, oil temperature indicator. In transformer, we are having the oil. So this oil is used as cooling medium to maintain the temperature of transformer. So what happens if the temperature of the oil increases? As per the standard, it should be 70 degrees centigrade. If it is going 80, 90, 100, okay, why the temperature will increase? Because if the demand of current is more, in that case, the temperature of oil may increase. So after one instant, what happens? The insulation of the oil will break, and inside the oil, you can expect a fire. Chance that fire may develop. Simple example that talk about your cooking oil when you're going to overheat. So inside your vessel, you'll be getting the flame, you'll be getting the fire. So same happens inside the transformer also. We have to maintain that. Again, we have the RMU, ring main unit. So we have two different types of supply. One is the radial, one is the ring. Okay, ring means what? One device will get the supply from two sources. Whenever any one source will have any kind of interruption, the other source will provide the supply. That is called as RMU, ring main unit. Radial means one device will get the supply from one side only. Again, the SWG, standard wire gauge. Every good manufacturing company will have some specific sizes like 1 square mm, 1.5, 2.54. When you talk about local manufacturing companies, they say it has 2.5 square mm or 4 square mm, but in practical, when you're going to measure, it will not be of the same size. So if you're working with good manufacturing company, you can expect the same size. Again, talking about SWA, steel wired armored. Every cable will have the armor. Every cable will have the armor. Like this is the armor. You see, especially the underground cables will have the armor. Or the high tension or the low tension side cables also will have the armor. So this is the armor. So we are talking about steel wire. We have aluminum wire also. We have steel wire also. It depends. Again, WTI, winding temperature indicator. Equipments like machine, generators, transformers will have the winding. So we have to maintain the temperature. While the temperature of the winding will increase, because if you're going to use for longer time, if you're going to overload, or if you're going to provide some unbalanced supply, in that case, the temperature of winding may increase. So to overcome that, we're having the WTI indicators. Next, triple VF, variable voltage, variable frequency. So nowadays for machines, we are having a technology called as VFD. Like we generally used to go with star delta or direct on-light in the olden days. But now we are going to use the VFDs, variable frequency drives. So in this variable frequency drive, we have a technology called as triple VF, variable voltage, variable frequency. So by varying the voltage and frequency, we are going to get a sine wave, a pure sine wave to overcome the losses. Next, we have the DOF, dropout fuse or burnout fuse or blown out fuse, I can say, if it is damaged.
Excuse me, sir.
Yes.
So VFD is having VVF, triple VF.
Yes.
Or-
VF is technology. VFD is the name of the process, and this is the technology what we use. This is the
You
kind of
VFD.
process to run your machine. Yes. SMFB, shielded maintenance free.
Sir, in this process, triple VF, how they control the number of cycles?
How we are going to control the number of cycles? By going with some polytronic switches like IGBTs, MOSFET, GTOs. Next, talking about shielded maintenance free battery, nothing but dry battery. Nowadays, you can see to your inverters or your UPSs, we are having the dry battery, just use and throw. These batteries will have a life of 48 months, 56 months. So by default, okay, after this age, you have to again recycle the battery. Again, JB, nothing but junction box. For your PVC conduit accessories, we have this. PB is for the push button, nothing but the call bell button, I can say. Again, TB, terminal box. If you're having multiple conduits going from one point to other point for a longer span, in between, we are having this terminal box so as to pull the cables very easily, as well as to maintain the cables also very easily in the future cases. Terminal box, we call it as. Again, the LCB, local control board or local control station. These are actually the two departments which we have at substation side. So whenever if we have any kind of interruption of supply, these people will get an alert message like so-and-so feeder has been blown out. Again, NONC, normally open, normally close. Every circuit breaker, isolator switch will have this mechanism. Normally open means circuit is open. Normally closed, circuit is closed. Circuit is healthy. Again, we have the ACCL, automatic change over current limiter. So this is actually a very new device in the market, which is offered by only one manufacturing company, nothing but Havells. Havells has got this device. So what it is doing is it is limiting the amount of current. For example, I have the interruption from the transformer side in my home. So I have a connection from the generator side also. But if in the generator, if I'm going to put the same amount of load, which I'm going to put from the transformer, so in that case, my generator may get overloaded because generator connection is provided only for the basic loads. So if you are going to put the complete load on the generator, same as transformer, so this ACCL will cut off the supply to overcome the overload on generator. So this is a very new device, ACCL. I'm talking about AC, alternate current or direct current, which we have discussed in the first class. A/C means air conditioning or air condition. There is much difference between AC and A/C. Please make a note, because generally if you're not going to write slash in between, it means that a alternate current. Again, AFL, above flow level or above finish level. Whenever you're going to mount anything like a light or a fan or a junction board or anything, so you should know these values, should know all these values, then only you can able to mark the levels in a very proper way. The marking will be very accurate in all the different areas or different rooms. Again, CCTV, closed circuit television. For the surveillance point of view, we are using EWE, electric water boiler. On the top of the roof, especially we have this, which is connected by means of solar panels. FL is flow level. For the mounting heights, the architects will provide you this value. FOC, fiber optic cable or your internet cable, I can say. Again, KHZ, MHZ are the units of frequency, kilohertz, mega kilohertz. MS, nothing but mild steel, a type of metal. NTS, not to scale. REV, revision, and WD is nothing but working drawing. These are actually the three things, especially on the drafting sheet we find. If you don't want to scale, or if you are having any kind of errors, you'll be getting the revision mark. Working drawing means approved and finalized drawing. Again, this symbol indicates phase. Again, this symbol indicates conduit. the PVC pipe. CD, candela, the unit of light. dB, decibel, the unit of sound. EF is exhaust fan, which we are going to use in wash areas or utility areas. ELEV, elevators or your escalators also again. Okay, elevators or escalators. Again, ECC, earth continuity conductor. Your earthing cable conductor is called as ECC cable. Like you can see, this is earthing, for example. Yeah, this is earthing for you. These cables are called as ECC cables. EM, nothing but emergency. F for the fuse. FA, fire alarm. KVA, the units of apparent power, kilovolt ampere. Okay, kVA, the units of reactive power, kilovolt ampere reactive. Watts, kilowatts, megawatts, the unit of active power. HP is for the horsepower. So these are the abbreviations which you have to memorize, which you have to understand. Then only you can able to deal with all these devices when you're going to design. I hope it's very, very clear for everyone.